Problem number 10. So I'm given the relationship A equals B over C, and then in each example problem I'm given two of the three pieces and asked to find the third. In part A, I know A and B, and I want to find C. I think I'll take care of the algebra first before I even deal with the numbers. So I have this formula, A equals B over C. I'd really rather the C be by itself because C is what I'm trying to find in this particular problem. So let me clear the fractions. That gives me CA equals B, and I can get C by itself by just dividing both sides by A. This version of the formula, C equals B over A, seems much more useful to me because now when I come over here to do the work, I know that I can get C by simply doing the calculation -8/9, the B, divided by 2/3, the A. How am I going to do that? Well, dividing by a fraction is the same as multiplying by the reciprocal, so I'll multiply by 3/2, dividing by 2/3, same thing. I'll look for some cross-canceling. I see a common factor of 3 as well as a common factor of 2, and I think then when I multiply across, I get -4 for the top, and it looks like 3 on the bottom. And so that's the value of C. C is equal to -4/3. In the second example, now I'm looking for B. So again, let me do my algebra first. Here was that original equation they gave us, A equals B over C. I would really rather have the B by itself. I can do that in just one step. As soon as I clear the fractions, this now says B is equal to C times A. Well, great. So in this particular problem, if I want to find B, all I need to do is multiply the C, -2√2 over 3, by the A, the √2 over 4. Let's see, do we have any canceling we can do? We actually do. √2 times √2 is just equal to 2. And then 2 times 2 is going to give me a 4 on the top, which means all of this will cancel out with that 4 down there. And so all I have left is -1 on the top and 3 on the bottom. And there's the value of B, -1/3. The other way that I could have worked problem 10 is by substituting the numbers into the formula first and then doing the algebra with the numbers already there. Problem number 11 says to rewrite each of these trig expressions using only sine or cosine. When I see cosecant, I think, well, that's easy. That's just the reciprocal of the sine function. So cosecant theta is 1 over sine theta. Similarly, secant theta is just 1 over cosine theta. Notice I'm really just using reciprocal identities to do that. How about tangent theta? Well, the reciprocal thing isn't really going to help me. What helps me here is the quotient identity. Tangent theta is equal to sine theta over cosine theta. Part D, same thing. The other quotient identity tells me that cotangent theta is equal to cosine theta over sine theta. Notice that we've taken each of the other 4 trig functions and rewritten them using only sine and or cosine. Problem number 12. I'm given some trig equations. I want to find all the solutions possible in this interval. So only angles between 0 and 2 pi, including the ends. We'll use the unit circles to help us here. We do want exact radian answers. Now when I look at part A, cosecant theta equals 1, obviously I'm looking for the angle. I'm being given the ratio or the coordinate. I think it's more helpful to think in terms of the big 3. So I know if the cosecant ratio is 1, that means the sine ratio is also 1, the reciprocal. That's just easier to think about. So where on the unit circle do you find a sine ratio or coordinate of 1? Well, on the unit circle, it's the b coordinate that the sine function sends out, and there's only one spot on the entire circle that has a b coordinate of 1. It is that spot right there, which means there's only one answer within one period. Anyway, obviously I could circle around a few times, but we're only looking for angles within that one time around, 0 to 2 pi. My answer here then would be pi over 2. Letter B, if the secant ratio is 1, then the cosine ratio is also 1. That seems easier to think about. Cosine represents the a coordinate on the unit circle. Now, the only spot with an a coordinate of 1 is this point right here. Here's 1 comma 0. So what angle does this represent? Well, obviously it represents 0 radians, but it also represents 2 pi radians, and we're allowed to go all the way up to 2 pi, right? There's that little equals there. So we want all the answers from 0 to 2 pi, including the ends. Both of those angles would satisfy the equation. Let's see, for the last one, cotangent theta equals 0. If cotangent equals 0, that would mean tangent theta is undefined, because the reciprocal of 0 doesn't exist. So I'm looking for the spots where the tangent function is undefined. Let's see, tangent is b over a on the unit circle. The only way that's going to come out undefined is if the a itself is a 0. If you have a 0 on the bottom, you don't have a value. So where would I have an a of 0? Here's one spot. This is the point 0 comma 1. And here is another spot. And I believe those are the only two spots. You're not going to find another place on the unit circle with an a value of 0. If you try to calculate the tangent for those two spots, it just doesn't exist. Well, one of those angles is right here, and the other angle is right here. I'm not going in a negative direction or spinning around more than once. I'm only doing between 0 and 2 pi. So that's going to give me pi over 2 as one possible answer and 3 pi over 2 as the other possible answer. In problem 13, I'm being asked to solve each equation for the letter A. Well, that means I'm going to need to get all the terms without an a on the other side. So I'm going to subtract that one over to the other side, giving me 2x squared minus bx squared y squared. And then I can get a by itself by just dividing both sides by x squared. A is now sitting by itself. Can I clean this thing up any? And the answer is yes. What I notice is that both terms on the top share this common factor of x squared, which matches what I have on the bottom. So I can go ahead and just divide that into both parts. I'm going to end up with a equals, let's see, 2x squared divided by x squared. The x squares would cancel, leaving me with just 2. Same thing in the other term. The x squareds would cancel, leaving me with just by squared. And so I don't even have a fraction. Here's the final answer where I've solved for the a. Let's try letter B. So I will subtract the x squared so as to get the term with the a sitting there by itself. That gives me 4x minus x squared. Once again, I'll divide both sides by x squared. And then I'm looking to simplify. Now, this time I notice that I don't have a common factor of x squared in both pieces on the top. I can only divide out what's in common. I do have 1x that's in common. Here's another way you can show the work if this is helpful. What I could do on the top is I could factor out that common factor of x, leaving me with 4 minus x in the parentheses. And then now that I've got everything in factored form, it's pretty easy to see that common factor of x. I could have done that in this example as well. I could have factored out the x squared on the top and then canceled the one on the bottom. That would have worked just the same. But here I'm dividing out that 1x. That'll cancel out one of these x's, and that's as good as I can make it. The final answer then to this problem, a equals 4 minus x on the top and then a single x on the bottom. I suppose I could also distribute this x to both parts, and so I'd get a equals 4 over x minus 1, and that would be fine, but it's generally considered better to have a single fraction on this side.